Get started in about a minute. All right, here we go. 11.6. Well, before we do that, any questions on 11.5? Now, I did give you the answers on that worksheet. So any questions?
I didn't understand how to do number 2 and 11 through 14.
All right. Let's take a look at that. All right, number 2. So we got that big ugly number 294. 294 ends in a 4. What multiplied by itself is a 4? That's a little bit more challenging. So whenever you get a large number like 294 and just nothing strikes you, well, you're just going to go through each possible perfect square. Is 294 divisible by 4? The answer is no. Is 294 divisible by 9? The answer is no. Is 294? I'm just going straight down the list. Now, I can probably make it a bit smarter because I know the last number ends in a 4, though. Is 294 after 9? That would be what, 16? The answer is no. Is 294 divisible by 25? I don't even need to check that one. 36. Is it divisible by 36? The answer is no. Is 294 divisible by what comes after 36? 36, that's 36, 49. So divisible by 49, ding, 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 we have a winner. So all I'm doing is I'm going through all those, I call it box 1, all those perfect squares until I find one that it works on. So it ends up being 49 times 6. So 49 times 6 is 294. The way we handle the variable one is from the rules yesterday. If it's even, when we take half of it. If it's odd, we subtract 1 and take half of it. So let's see. The square root of 49 is 7. So we're done with the 49. N is to the 3rd power. So we subtract 1 from 3, we get 2. Half of 2 is 1. So n's on the outside, and there's going to be an n left on the inside. And then what's left that I haven't crossed out? The 6 and the aforementioned n. So there's your answer. That's where that one comes from. Okay, what were your other questions, Haley?
11 through 14.
All right, 11 through 14 are the equations. Now remember, we're just going to solve it the way we normally solve one. Pick one.
Let's do number 13.
Okay, number 13. So let's see, number 13. I mean, that's perfectly fine. The 14 is a little bit harder, but we'll do 13. So first thing I'm going to do is I'm going to get rid of addition and subtraction. I mean, it's just regular algebra. Subtract 7 from both sides. I get 7x squared is equal to 7. Get rid of that 7 through division. So I'm going to divide both sides by 7. 7's cancel on the left side and run out of space here. So we got x squared is equal to 1. I need to get rid of this 2. We get rid of squaring by square rooting, but as soon as I take the square root of x, I'm out of space here. I know that the answer is going to be plus or minus 1. All right, it looks messy, but that's how you do it. Plus or minus 1. Square root of x squared, it's even. Half of it is 1, so we're left with x. The square root of 1 is 1, so x is equal to plus or minus 1. Only for these equations right here, when you take the square root of a variable, you have to assume that the answer could be positive or negative. Why? Because there's two numbers squared that is 1. 1 times 1 is 1, and -1 times -1 is 1. That's why you get that plus or minus right there. All the rest of them are done exactly the same way. Hey, number 14, subtract 7, then divide by 3, then take the square root of whatever's left there. The answer will be plus or minus whatever. Okay. So that's how those are done. And like I said, here are the answers. Here are the answers. Now, notice they didn't write the answer as plus or minus 1. They wrote it as 1 comma -1. It's the same answer, just a different way of writing the answer. Some books write it this way. Some books will write plus or minus. Okay, so back to where we were at. Where were we? We were on, did I hit array? No, I didn't. Okay, we're good. Talking to myself. Okay, don't get lazy. Make sure everyone's turning in their homework. Harley, I can hear you sending me a whole bunch of messages, but I can't answer anything while I'm teaching. Okay, so 11.6, looking at the schedule. Remember, you are coming in on Tuesday to take your PSAT test. So even though we're still in quarantine until that following Monday, you are coming in on that Tuesday to take your PSAT test. Don't forget your graphing calculator. Make sure you have charged batteries when you show up. That's all you're doing on that Tuesday. No class, no homework, just one PSAT test, and you go home. The next day, we're going to do the chapter. Next 2 days, we'll do the chapter 11 reviews. Then we'll take the chapter test next week on Friday. We jumped into chapter 12, the last chapter of the book. That'll bring us in. This is the first week of May. Second week, we'll finish chapter 12. That third and fourth week, the third week, towards the middle of the week, we start doing a semester review. And then the last week of May, nothing but finals. 1 or 2 finals every day. I'm sorry. Yeah, 1 or 2 finals every day. It'll be half-day schedules that last week of May. And then we're done. School's out for summer. All right, here's your homework tonight. You're going to like today's homework. It's pretty simple. It is also a repeat of something that you learned in 8th grade last year. They make it slightly more challenging. The numbers will be slightly uglier than they were in 8th grade. But you guys have seen this before. Today should be nothing but a review. Nothing but a review. Okay. I'll have this posted, I don't know, probably within as soon as it uploads. So as soon as I post the video, if you immediately click on it, then it's still loading on YouTube. So it takes a while. So even though I'll post the video, it may take I don't know, 5 minutes or something for it to upload to YouTube, even though the link will be there. Yeah, today we're doing the Pythagorean theorem. Simple stuff. Pythagorean theorem. All right, so let's talk about the Pythagorean theorem. So first off, my geometry students already know what a theorem is because they get multiple of these every single class. A theorem is a mathematical rule. It states specifically either how you can do something or a specific requirement dealing with certain things. So for instance, a mathematical theorem might say something that the area of a rectangle is base times height. So it's called a mathematical rule. So when you're calculating the area of any rectangle, you multiply base times height. And so we're dealing today with what's something called the Pythagorean theorem. So Pythagorean theorem comes from a guy named Pythagoras. He was a Greek philosopher and mathematician a very long time ago. There is a statue or a bust of him. And his theorem deals specifically with just right triangles. So only right triangles, not all triangles, but right triangles. By the way, we don't know if Pythagoras was actually the first guy to come up with this, but he was the first guy that wrote it down in a book and therefore he gets credit for it. Many civilizations came up with this theorem, but he was the first to put it in a book, and he's the one that we can date it to, the earliest known example of it written down. So he gets credit for it. So once again, it only deals with a right triangle. So let's review the parts of a right triangle. We haven't seen this at all in Algebra 1, but we did see this in 8th grade. So I start off with a right triangle, and the right triangle has a few parts. First off, it's a right triangle specifically because one, not two, not three, but one of the angles is 90 degrees. And the angle that is equal to 90 degrees, therefore right angle, equal to 90 degrees, we indicate that with a little square. A square is a quadrilateral where all four angles are right. Therefore, that square is what indicates right angle. Okay, so we have a right triangle, right? The two parts of the triangle that make that right angle, we call legs, right? Each one is called a leg. Now, unless it's an isosceles right triangle, the legs will be of different distances. So we don't call the long one something and the short one something. We just call them both legs. But we do have a third side, and that is the side that is opposite. That right angle. Notice where that red arrow is pointed. So it's pointing to the side that is opposite. The side that doesn't form the right angle, we call that the hypotenuse. All right, so that is the hypotenuse. So right triangles have two legs and a hypotenuse. And the hypotenuse is the side that is opposite the right angle, and the legs are the two sides that form the right angle. Now, right triangles can come in a whole bunch of different forms. You can have an isosceles. You also can have a scaling right triangle. You can't have an obtuse right triangle because as soon as you have one angle that's 90, there's only 180 degrees in a triangle, so you can't get to an obtuse angle from there. So therefore, there are no obtuse right triangles. There are only acute right triangles, and some of the acute ones are isosceles. Okay, cool. So it turns out for math students, the hardest thing about the Pythagorean theorem is finding the hypotenuse. So here's a slide where we just simply, I'm going to show you where the legs and the hypotenuse are for each one of these triangles. Now, I tried to arrange the right triangle, every single possibility. For instance, the upper left one there, let's see, the side that is opposite the right angle, that dotted line, that's just an indication. I'm not actually drawing or measuring anything. It's just showing you where the hypotenuse is. As soon as you identify the hypotenuse, the other two sides are your legs. All right, look at the red one there. Red one, I just kind of flipped it and rotated it a little bit. Well, remember the side that is opposite the right angle is the hypotenuse, and the other two sides are your legs. The two legs form the right angle. The hypotenuse is opposite the right angle. If I flip it around or continue to flip around, I can get it to where the hypotenuse is not on the top or the left side. That upper right one, notice that the hypotenuse is, I guess we would call that on the right side. The other two sides of the leg. It turns out that those three right there are not the ones that ever give students problems. The one that gives students problems is that last yellow one there. And the reason is they're so used of seeing the triangle like it's indicated here in blue and red that they immediately assume that either the left side or the right side of that triangle must be the hypotenuse, because most of the triangles you see are like that. This one, however, notice where the right angle is. It's on the top. So therefore, the side that is opposite would be the hypotenuse. The other two sides would be the leg. Take a really long look at that last one. If you make a mistake on the Pythagorean theorem, most likely it's because you don't have the right hypotenuse. Okay, so we did that last year, by the way. We did a lot of this last year. We did a whole chapter on the Pythagorean theorem. We're only doing one section here. So remember that one that will give you problems, the side that is opposite the right angle is the hypotenuse. Okay, so now on to the Pythagorean theorem. Did anybody remember it from last year? What is the Pythagorean theorem? Anna, Haley, Kaylee, Riley, Piper. Any of you remember what the what is it? It's a formula, by the way.
I don't remember.
Okay. So here's what Pythagoras said. He said that if you Well, the hypotenuse is the side opposite the right triangle. He said, let's call that C. And let's call the other two sides, the two legs, we'll call them A and B. And here's what he said. He said, if you square A and you square B and you square C, that the sum of the squares of the two legs equals the square of the hypotenuse, right? If A and B are your two legs and you square both of them and then add them together, that it will equal the hypotenuse squared. For those of you in geometry, we prove this. I don't know if you're to that chapter yet or not, but we prove this. For those of you that are only in Algebra 1, next year you will prove this. All right, so that is the Pythagorean theorem. A squared plus B squared equals C squared. It's one of those math formulas that if you ask any adult that's been through high school, what do they remember from math high school? This is one of the formulas they probably remember. Oh yeah, A squared plus B squared equals C squared. You use this so many times, so many times. There are a whole lot of math. I don't care how much more math you take, almost every year you're going to be doing the Pythagorean theorem at one time, obviously in geometry, but it turns out in Algebra 2 and pre-calculus and calculus, we use the Pythagorean theorem all the time. It's widely used. All right. That is the formula. Make sure that you have that written. So if you have a right triangle with the legs A and B, and C is the hypotenuse, then A squared plus B squared equals C squared. So in geometry, just a precursor for what will happen next year, we actually prove this. And we kind of draw these weird shapes. You can't even see where the right triangle is here. We draw these weird shapes and we do this thing called proving it. Like I don't just say, right now you got to trust me in Algebra 1 that it's true. In geometry, what you'll find out is geometry, although it's absolutely about shapes, it's mostly about proving things. And so we'll spend a whole day proving that one little theorem right there. For Algebra 1 and 8th graders, I basically don't prove it to you, but I do show you a quick video. So remember the Pythagorean theorem says that if you square a side and add it to the square of another side, it equals the square of the third side being the hypotenuse. Well, when you square something, you are literally making squares. So the video I will show you, I mean, it's not a true mathematical proof, but it definitely indicates what's going on. So she has a right triangle in the middle, and she takes each side, the two legs and the hypotenuse, and that side length, she makes a square out of them. I mean, literally, there's a square there. And in each one of those squares, she fills it full of, in this case, blue water. And what she's showing there is that if you add the two legs together, it equals the square of the hypotenuse, or the square that's made with the hypotenuse. There we go. On the top two there are the two legs. On the top two right there are the two legs filled with blue water. And when you pour the blue water from the two legs, it fills into the square made up of the hypotenuse. I mean, that's a pretty nifty gadget she has right there. I've always debated whether or not I want to build one of those. And it visually gives you an understanding of why this Pythagorean theorem works. I'll just say that it's not rigorous enough for us in the mathematical sense to use that as a proof next year in geometry. So next year we go through the fun of proving it mathematically. This year, I simply show you this one little quick video and say, hey, trust me, A squared plus B squared equals C squared. Okay. So the rest of the class is simply doing the calculations. Literally, I will give you a right triangle where one of the sides will be missing. You will calculate the third side. So here's how it's done. Well, remember, this only works with right triangles. So I guess step number one is you have to indicate, or you got to make sure you have a right triangle. Hey, look, I do. But once that's done, the rest is pretty simple. But I will say you have to make sure that you have the right hypotenuse. I would always, even if I were doing this by hand, I would always indicate as step number one, I would indicate where the hypotenuse is. Notice the hypotenuse is opposite the right angle. So the side that I don't know on this triangle is the C value. Now I simply take those three values, 3, 4, and C, and throw them into the Pythagorean theorem. It doesn't matter which side is A or B, but it does matter which side is C. So if I consider that 3 is the value A and 4 is the value B and C is the value, well, C, then I do that math. It says square A. So that would mean 3 squared plus 4 squared would equal to C squared. Don't forget to square your hypotenuse. Now it's just a matter of math, and now you can see why Haley, yesterday, we solved some equations that look like this. 3 squared is 9, 4 squared is 16. 9 plus 16 is 25. Okay, now it looks like yesterday. Yesterday's homework, at this step, we would say take the square root of both sides, and we have to consider that the answer is plus or minus. Remember the statement I made yesterday in class. I said that in algebra, absolutely positively, there's 2 numbers squared that are 25, 5 and negative 5. But if I claim that one of the answers is negative 5, that makes no sense. I can't have a side length of 3, 4, and negative 5. Negative 5 is not a side length. So in geometry, we exclude the negative square root and only consider the principal square root. So when I take the square root of both sides here, yes, if this was an algebra problem, we would say the answer is plus or minus 5. But in geometry, only one answer here. It's just 5. Just 5. All right, let's see that again. Let's see that again. All right, I have a right triangle. I have a side length of 5, a side length of 6. They are both the legs. How do I know that they're legs? Because they are the 2 sides that form, encircled here, form that right angle. Okay, so the opposite side to the right angle is my C value. Label that. Now I simply just plug those numbers into the formula. Doesn't matter which is A and which is B. Either one of the legs could be A or B. What matters is which one is C. All right, so that's going to give me 5 squared plus 6 squared equals C squared. You just do that math. Hey, if you haven't memorized box 1 by now, right, you will soon. 5 squared is 25, 6 squared is 36. 25 and 36, do that math for you really quickly, is 61. Now here we run into an issue. 61 is not a perfect square, and there is no perfect squares inside of 61. So tonight for homework, when you do this math, they don't want, if you can, simplify the square root, right? This one you can't. Square root of 61, there's no perfect squares. So they literally want you to take your calculator and take the square root of 61. I believe the instructions say round to the nearest tenth if necessary. Now remember, square root of 61 is an irrational number. It goes on forever, never stops. So you can't use an equal sign. You have to use the approximate symbol there, the 2 wiggles. All right. Any questions so far on what I've done? You remember doing this last year? Pythagorean theorem? All right. Let's do another one. Let's see, the 2 legs here are 6 and 8, and the hypotenuse, how do I know it's the hypotenuse? Well, it's the side that's opposite the right angle. Be careful. I'm showing you the triangles as you would think that they would look like. I can turn that triangle on its side very easily. All right, let's see. Doesn't matter which one is A and B, it only matters which one is C. C is the side that's opposite the hypotenuse, or opposite the right angle. So that's going to be 6 squared plus 8 squared equals C squared. Stop me if I'm going too fast. 6 squared is 36. 8 squared is 64. 64 and 36. Hey, that's 100. And if I take the square root of both sides, hopefully you got box 1 memorized. Square root of 100 is 10. Remember, last night's homework, yeah, it's confusing. If it's just an algebra problem, the square root of 100 is plus or minus 10. Or I should say, if you solve the equation, C squared is equal to 100, then yes, the answer is plus or minus 10. But in algebra, well, negative 10 couldn't be the length of side C, right? So it's only could be 10. All right, 2 more. See if you can do these all by yourself. I'll give you a minute or so head start, and then I'll solve these both. All right, the one on the left there. As always, I would absolutely 100% find the hypotenuse first. The other two sides are your legs. So the missing side here is your C value. 4 squared plus 3 squared. Oops, that's the answer. I guess I have to do some. Why are you doing this? I'm using someone else's computer. My computer's getting its battery changed. All right, back to this. Come on, computer, you can work. All right, so let's see. That would be 4 squared plus 3 squared. And that's going to equal C squared. 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. So I get 25 is equal to C squared. Last step, take the square root of both sides. And we get C is equal to 5. Yay. All right, for the second one, once again, the side that is opposite the right angle is your C value. The other two are your A and B. So let's see, 12 squared plus 5 squared is equal to C squared. Okay, 12 squared is 144. Your familiarity with box number 1, and remember when I say box 1, I'm talking about box 1 from that first lesson when we talked about perfect squares. Plus 5 squared is 25, and that equals C squared. All right, 144 and 25 is 169. If you have familiarity with that box number 1, you'll realize that 169 was one of those perfect squares. That was 13. So C equals 13. I'm skipping putting the square root around both of those, but I probably should. Square root both sides. Square root of C squared is C. Hey, it's even. Half of 2 is 1. So technically that's C to the first power. There you go. That's how that one is done. That's how that one is done. Okay. I've lost my button here. Let me punch a few more buttons here. There we go. That's what I want. All right. So the two answers for this one, as aforementioned, was 5 and 13. Very good. Now, if you notice all those problems that we just did, we did not know what the hypotenuse was. Well, what happens if we know the hypotenuse and we're missing one of the legs? So here's one like that. Notice the side that is opposite. I'm still putting that dotted line there because I always want to identify the hypotenuse first. Yes.
We can't. You stop screen sharing.
Well, that would be
Yeah,
bad.
we can't.
Share. How about now?
We can see it.
Yeah.
Okay.
We're good.
So we are missing one of the legs because I know the side that's opposite the right angle is the hypotenuse. So 13 is the C value. What I'm missing is, well, you could call it A or B. Doesn't really matter. I'll call it B. It's the same process. We plug the numbers in. So A is 12 and C is 13. We're missing the B value. And I simply go to town on the math. 12 squared is 144. 13 squared is 169. Now notice, a little bit different here. I got to subtract 144 from both sides. Straight up algebra, no big deal. So I subtract 144 from both sides. Let's see, that gives me 25. Oh, there's that 25 again. Very popular. We take the square root of both sides. We get B is equal to 5. Done. By the way, this is the same problem as the previous one. I just made the B value the one that was missing. All right, so let's see that again. Notice sometimes it's hard to tell what you're missing, so I would always indicate where the hypotenuse is first. That tells you what the C value is. So the C value is 26. I don't care whether you call the other side A or B. It doesn't really matter. I'm going to call it A. So I'm missing the A value. So I'm going to be solving for the A value. So that would be A squared plus 10 squared is equal to 26 squared. All right. Well, I can do 10 squared easily in my head. That's 100. But 26 squared, I'm either reaching for a calculator or I'm reaching for scratch paper. 26 squared is 676. 676. Well, it's pretty clear what to do to both sides here. Subtract 100. So we subtract 100 and we get 576. Once again, 576 is not on our sheet of paper that gives us all our perfect squares. Well, it turns out that it's 24. So they are going to make you do a couple. So let's see, how could we have figured out by hand without a calculator that it was 24? So we're going to use our skills that we learned the other day with 576. So 576, right, we're trying to take the square root of that. Well, it is divisible by 4. 4 goes into 5 one time, remainder 1. 4 goes into 17 4 times, 16, remainder 1, and 4 goes into 16. So 144. So 144 times 4, Anna, this is one of your favorite ones, is 576. And Anna's learned that once you get this, you take the square root of both. The square root of 144 is 12. The square root of 4 is 2. And 2 times 12 is, in fact, the 24. So even though there's some really weird ones that are not in box 1, right? Well, obviously you have a calculator, it's pretty easy. But if you don't have a calculator, don't immediately assume, throw your hands up. You're like, well, I can't figure this one out. Use those skills that you already have. Those skills of simplifying a very large square root. All right, did I lose anybody on that one? Okay, cool. Moving on. All right, so let's do these two. I'll give you about a minute head start, and then I'll solve both of these. All right, so the first one, like I said, I always draw this arrow because it keeps you from making a silly mistake. So that's my C value. So I'm missing my A value. So let's see, A squared plus 8 squared. A couple of you are probably already saying, could I just write 64 instead of writing 8 squared? Yeah, you can do that. Is equal to 10 squared. And you're like, can I just write 100 instead of 10 squared? So remember, if you can do this in your head, that's fine. But then we get to a number like, I don't know, 25, and you can't do it in your head. So A squared plus 64 is equal to 100. Subtract 64 from both sides. Run out of space here. 64. And I believe we get what, 36? Yeah, we get 36. So we get A squared is equal to A squared, sorry. A squared is equal to 36. And the square root of 36 is 6. So A is equal to 6. There we go. I'll do the other one up here. So if 25 is your hypotenuse, we're missing A again. So A squared plus 7 squared is equal to 25 squared. Okay, I'm going to need a calculator to do some scratch work, one of the two. I don't know that one off the top of my head. So we got A squared plus 49 is equal to, I can do that one by hand, but I'll just use my calculator here. 625, 625. We subtract 49 from both sides. Let's see, 9 from 15 is a 6, 4 from 11 is a 7. Oh, look, we got our friend 576. You remember this from the last problem? Sometimes you can get lucky like that, and you just get this perfect square that you realize is a really common one, right? Do you remember what the answer was from the previous one? It was 24. So A is equal to 24. Now, once again, if you couldn't remember that, then we would have to do that. Once you take the square root of both sides, you'd have to break 576 into, I believe we did 144 times 4. So that would be 12 times 2, which is 24. Cool. Any questions on what we just did? Don't be intimidated by large square roots.
You said we're allowed to use our calculator on the homework?
Yeah, but I'm just saying, when you get something like 576, it's really easy to just take the square root of 576. What I would like you to do is try to do it by hand, right? Now, if you do use a calculator, right, the way that I would like you to use it is not to hit the square root button, but if you had 576 and you're like, well, I don't know what the square root of that is, take that and divide it by all the perfect squares, right? Take 576 and divide it by 9, then divide it by 16, then divide it by 25, so forth. Eventually, when you divided it by 144, actually, you would have gotten this when you divided it by 4. It would have been one step. You would see that it's 144 times 4. At least then you're getting the practice of simplifying a square root rather than having your calculator do all the work for you. When you get to geometry next year, you're going to have to be able to do this by hand, right? All right, we have one thing left. It's not as bad as it seems, and it's the question, which side is the longest? If you have a right triangle, which side is the longest? Well, here are the answers to the previous problems that we just did. So on that first one, we got that A was 6, so I can scratch out this A and write a 6. On the second one, we got an answer of 24. So on any right triangle, which side is always, what in the world just happened? On any right triangle, I have no idea why I did that. Come on, computer, you can work. Help me out here. It's not playing with me. If you could see my face right now, I'm frustrated. I have no idea what you would be loading, computer. All right, back to my question. For any right triangle, what is the longest side? For any right triangle, what is the longest? Is it A, B, or C? Somebody answer.
C.
It's always, 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 always the hypotenuse. It is always the hypotenuse. We are going to use that fact to answer the next questions. And the next questions, if my computer finally, I have no idea what it was doing there, is going to be this game of, is it a right triangle? I'm going to give you 3 values. Now, 3 values might make a triangle. Not all 3 values will make, or I'm going to give you 3 segments, and I'm going to tell you their lengths. Now, not all 3 segments can ever make a triangle. Only certain ones can. And then of those ones that can make a triangle, only a special kind of ones, special relationship, can make a right triangle. So the game is this. I'm going to give you 3 measurements. These represent 3 segment lengths, 3, 4, and 5. And the question is, do these make a right triangle? Well, it sounds like we would need a new formula, but in fact, we can simply use the Pythagorean theorem, and knowing, you just said, that C is always the longest side. So here are the steps. If you want to play the video again when you're doing your homework, that might help, or you write them down right now. Step number 1 is you're going to, here's the problem. They're going to give you 3 lengths, and they're going to say, can these 3 lengths make a right triangle? So step number 1, you just write the Pythagorean theorem. Step number 2, you find the longest side here, 3, 4, 5. What's the longest side? 5. 5 is the longest side. 5 will become your C value. Your other 2 values are going to be your A and your B. So you write Pythagorean theorem. You look at the 3 numbers and you say, hey, look, 5 is the biggest number. 5 becomes your C value. Your other values are your A and your B. So we plug those numbers in. So next step, plug in the numbers. The last step, or second to last step, is you see if the left side, or you evaluate both. I mean, you literally just do the math. 3 squared is 9, 4 squared is 16, 5 squared is 25. The last step is you see if the left side does in fact equal the right side. So check it out. 9 plus 16 is 25. So yes, I'm just seeing if the left side equals the right side. So it's going to be a yes or no answer. So in this case, yes, those 3 side lengths do form a right triangle. So what would it look like if it was no? Well, when we simplify, we're going to get 2 different numbers on the left and right side of the equal sign. So maybe we should do an example like that to see what it would look like if the answer was no. Steps are right there. Step number 1 is we write the base. We just basically write the Pythagorean theorem. Step number 2 is we figure out which side is longest, 12, 10, or 20. Well, clearly 20 is the longest side. If it's a right triangle, then 20 will be your C value. So I plug in 20 for C, 12 and 10 for A and B. Stop me if I'm going too quick. So all I'm doing is plugging in the biggest value for C and the other 2 values for A and B. Now I got to square everything. All right, so 12 squared is 144, 10 squared is 100, and it turns out that 20 squared, as you might imagine, is 400. That wasn't one of our 16 perfect squares, but I think you can do 20 times 20. All right, last step, if you see if the left side equals the right side. So 144 plus 100, is that 400? Heck, no, it's not. So this is what it will look like if the answer is no. So no, those 3 side lengths do not make a right triangle. They might make a triangle. I don't know that. You'd have to use some algebra or geometry skills that I'll teach you next year. But what I do know is that even if it does make a triangle, it's not a right triangle. Tonight for homework, it's going to be yes or no. Does it make a right triangle or doesn't it? All right. Let's do these together. And then I believe that's the last thing we do today. Quick class today because most of it was review. All right. So I have 2 problems here in yellow. So let's see. Does it make a right triangle? Does it make a right triangle? So the steps are step number 1, you write A squared plus B squared equals C squared. And I know some of you are probably screaming, that seems dumb. Why don't I just plug the numbers in right from the very start? Okay, you got me there. That would probably be smarter. But I'm going to keep to my 4 steps here. All right, we got to identify the largest number. The largest number is 15. That becomes my C value. And the other 2 values are your A and your B value. So it doesn't matter which one's A or B. So that's 9 squared plus 12 squared. And I know you're screaming at me, why don't I write 81 and 144 right from the start? You can. I'm just showing you all the steps. Equals 15 squared. 9 squared is 81. 12 squared is 144. And 15 squared, that's a tough one to remember. That's why I want you to have these memorized, is 225. 225. Does 81 and 144, I got to do some scratch work here. 144, 81. Does that equal 225? 1 plus 4 is 5. Looks promising. 4 plus 8 is 12. Carry your 1. 1 plus 1 is 2. Yes. Ding, 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 ding. Check. So this is a big fat yes. Those 3 side lengths do, in fact, make a right triangle. If you're following the math teacher rule, then obviously the next answer should be a no. All right, let's see if I did it or not. Step number 1, you write the base Pythagorean theorem. A squared plus B squared equals C squared. Yes, you can plug the numbers in right from the very start. And yes, if you can square them right from the very start. The biggest number here is 20. The other values will be A and B. So your 20 will be your C value. All right, so let's see. 15 squared. Yeah, you could have written 225. Plus 12 squared. Yes, you could have written 144. Is equal 220 squared. Yes, you could write 400. So now I'll catch up with you. So 225 plus 144 is equal to 400. And I think you can see without even trying to do scratch work on that one, there is no way. Oh, I wrote 200. It's 400. There is no way that 225 and 144, 4 plus 5 is 9, not 0. So there's no way that this makes a right triangle. It could make a triangle. All right. Next year, I'll teach you how you can figure that out. But no, it doesn't make a right triangle.
Mr. C, if we can tell that it is like no or it's yes, then do we have to write out the scratch work for the homework?
Absolutely no. If you can tell at the point that you can, but you got to make 100% sure. I mean, obviously, yeah. As soon as I wrote 225 plus 144, I mean, I could have stopped right there. So the answer to your question is yes. Okay. Questions. By the way, here's the numbers you would have gotten. Questions on anything we did today? We like short classes. Pythagorean theorem is fun. And like I said, you're going to be using this. We're going to do some more things with the Pythagorean theorem this year, but not too many more. Next year, we do lots of things with Pythagorean theorem. All right. Any questions on anything I covered today? All right. You guys stay motivated. Make sure, well, you six always do, but stay motivated. Make sure you do your homework. Make sure it gets turned in. And I will see you guys tomorrow. Have a wonderful day. See you later.